Dr. M. Wilson is happy to welcome you all. This is the YouTube channel MWN.com. Greetings from MWN.com. Dr. M. Wilson, author, publisher, professor of commerce and management and formerly vice principal and head of Department of Commerce, Scott Christian College, Nagercoil is delighted in presenting this session. Thank you. Please subscribe the channel MWN.com. 2. Geometric mean. Meaning and definition. Geometric mean is the nth root of the product of observations in the series. The formula for calculating geometric mean is well presented here. Logarithm of each variable should be calculated and recorded in the second column, and then the total of it should be calculated and it should be divided by 7 since the total number of variables is 7. Then anti-log of that value should be calculated to know the geometric mean. Calculation of GM for discrete series. Formula is mentioned here, where f equals frequency, log x equals logarithms for variable x, n is total number of variables. It's noted from the table that the first column is variables, here its production, second column is frequencies, here its number of factories. In the third column, the logarithm of variables mentioned in the first column should be recorded, and then it should be multiplied by respective frequencies mentioned in the second column, and then sum of all such values should be calculated and it should be divided by the total number of frequencies, which is 50. Then anti-log of such value should be calculated. Calculation of GM for continuous series. Formula is mentioned here, where f indicates frequencies, log(m) indicates logarithms for the mid-value of the classes, and n indicates the total number of frequencies. The illustration is related with daily income of workers. It's noted from the table that the first column is variables, here its income, second column is frequencies, here its number of families. In the third column, the midpoint of each variable should be written. For example, the midpoint of 100 to 200 is 150. It's calculated by adding 100 to 200 and dividing by 2. In the fourth column, the logarithm of variables mentioned in the third column should be recorded, and then it should be multiplied by respective frequencies mentioned in the second column, and then sum of all such values should be calculated and it should be divided by the total number of frequencies, which is 45. Then anti-log of such value should be calculated. Merits of geometric mean. 1. It is rigidly defined. 2. It can be used for averaging ratios, rates and percentages. 3. It is suitable for calculating index numbers. 4. It can be used for further statistical analysis. Demerits of geometric mean. 1. It is difficult to calculate and understand. 2. Geometric mean will be 0 if any of the value in a series is 0. Hence, it cannot be calculated for such kind of series. 3. It cannot be calculated when the distribution has open-end class. 3. Harmonic mean. Harmonic mean is the total number of observations divided by the sum of reciprocals of the numbers. It can be calculated as follows. Calculation of harmonic mean for individual observation. The formula for harmonic mean is mentioned here. N equals total number of variables and is the total number of the reciprocals of variables. The variables given in the illustration is written in the first column. 1 is divided by each variable should be calculated and recorded in the second column. For example, 1 divided by 7, that's 0.1429. It's noted from the table that the first column is variables, here its wages, second column is frequencies, here its number of workers. In the third column, each frequency is divided by each variable should be calculated and recorded. For example, 5 is divided by 50, that's 0.1 for the first row, then sum of all such values should be calculated and it should be divided by the total number of frequencies, which is 50. Calculation of harmonic mean for continuous series. The formula for harmonic mean is mentioned here. It's noted from the table that the first column is variables, here its marks, second column is frequencies, here its number of students. In the third column, the mid-values of all variables in the first column should be calculated and recorded. In the fourth column, each frequency is divided by each mid-values should be calculated and recorded. For example, 9 is divided by 15, that's 0.6 for the second row, then sum of all such values should be calculated and it should be divided by the total number of frequencies, which is 50. Merits. 1. It takes into account all the observations. 2. It can be used for further algebraic analysis. 3. It can be used for averaging rates and ratios. 4. It is rigidly defined. Demerits. 1. It is difficult to understand and to calculate. 2. It cannot be calculated if any one or more values of the variables is 0. 3. It cannot be calculated if there exists both positive and negative values in a series. Relation between arithmetic mean, geometric mean and harmonic mean. The arithmetic mean would be greater than geometric mean and harmonic mean. Geometric mean would also be greater than harmonic mean. Hence, AM is greater than GM is greater than HM. If all the items of the data are of same value like 25, 25, 25, 25, 25, then the arithmetic mean would be equal to geometric mean and harmonic mean. That is AM equals GM equals HM. It's noted from the table that first column represents variables, second column is log x, and third column is 1 divided by x. These columns are meant for arithmetic mean, geometric mean, and harmonic mean respectively. The procedure of calculations is already well explained.